Good evening and Jahan, students of class 12. As you know that due to corona lockdown, CBSE has presented a new syllabus. According to that, solid state you have to study. In solid state, whatever topics are given for your study is first electrical nature of solid, electrical nature of solid and magnetic behavior of solid and magnetic behavior of solid. You have to study only these two topics in class 12. क्लास 12 में जो नया सिलेबस सीबीएसई की ओर से जारी हुआ है उसमें सॉलिड स्टेट आपको पढ़ना है। पिछले साल सॉलिड स्टेट नहीं पढ़ना था और इसके दो टॉपिक ही केवल आपको पढ़ने हैं, इलेक्ट्रिकल नेचर ऑफ सॉलिड एंड मैग्नेटिक बिहेवियर ऑफ सॉलिड। केवल दो टॉपिक आपको पढ़ना है जो सीबीएसई ने सजेस्ट किया है। अब हम लोग इस दो टॉपिक को पढ़ने की कोशिश करते हैं। इलेक्ट्रिकल नेचर ऑफ सॉलिड, electrical nature of solid. As you all know that an atom is made up of proton, electron and neutron. Proton and electrons are electrical particles. Due to the presence of electrons in the solid, it shows electrical behavior. As for electrical behavior, solids are of three kinds. First one is your conductors. So what are conductors? You have studied this topic in class 9, class 8 also. The topic is very easy to understand. Normally all metals are conductors. So what is the specialty in conductors? Conductors are those solids which conduct electricity, are those solids which conduct electricity are called conductors. Normally the conductance of solids are of high order. Normally the conductance of solid is of high order. As per your know-how, what kind of solids are conductors of electricity? It's known to you, the solid which are conductors of electricity are metals. All metals are conductor of electricity. Any metals, there is two type of question, which is best conductor of electricity. One, which is the best conductor of electricity, and the answer is known to you. And what the answer is? The answer is silver, which is represented by Ag. Second, which is the worst conductor of electricity? Which is the worst conductor of electricity? Now here, as they are the part of general knowledge and they must be known to you, what is that? The worst conductor of electricity is Pb, that we call lead. This is what about conductors. Thereafter we will study about semiconductors. See here, the second type of solids which we are to study now is semiconductors. Semiconductors. Here, semiconductors. Semiconductors. The solids whose conductivity is not high. Conductivity is not high, but below moderate. But below moderate is called semiconductor. Is called semiconductors. And the example is very simple. Metalloids. All metalloids normally set the example. An example, the two famous things here, silicon and germanium. They are semiconductors. And third type of solid is also present according to electrical behavior, and that solid is called insulator. The third type of solid which we are to discuss now is insulator. Insulator means bad conductor of electricity. Insulator means the solid through which electrical current can't be passed is called insulator. And now if you want to say the example is very easy. Non-metal. Normally all the non-metals are insulators, and one exception is here. And what that exception is? Exception is graphite. Graphite is the only non-metal which conducts electricity. So this is what your topic is. According to electrical behavior, the solids are of three kinds. One is called conductor, another is semiconductor, and third one is what? Third one is your insulator. Examples are very easy. For conductor, all metals are conductors. In metals, silver contains maximum current, and lead conducts minimum current. And now here in semiconductors, the conductance is not of high order, but it is in middle range. And this is the example is metalloid, in which two elements must be clearly known to you and keep in your mind all the time. And that is silicon and germanium. An insulator whose conductance is very low, it is not of commercial utilization. And here the example is all non-metals. Only one non-metal is known to the scientific world which conducts electricity, and that is your graphite. Now, here we will try to understand the concept which is developed to explain the electrical nature of solid. One theory is there which throws light on the nature of solids as per electrical nature is concerned, and that theory is called valence band theory. This is the theory which explains the electrical behavior of the solids. It is your valence band theory. Here one thing should be understood very clearly. What is valence? Valence means all valence electrons are not free. Only this much: valence electrons are not free. They are in bond. They are in bond. As they are in bond, they are not free. So no metal can conduct electricity without providing electrical potential. See, as electrons are in bond, in metal, and here one term is known to you, that we call metallic bond. As electrons are in bond in metal, that's why they can't conduct electricity. They can't conduct electricity. They can't conduct electricity because for the conduction of electricity, free electrons are required. This is the basic concept of the theory. This is valence band theory. Takes into account that valence electrons are not free. They are in the form of bond that we call metallic bond. As they are bonded, so they can't conduct electricity by themselves. For that, we have to supply electrical energy, and that electrical energy is measured in volt, that we call potential difference. When bonded electrons will liberate, only then they can conduct electricity. After liberation from bonded position, the electron moves into conduction band. What happens? When electrical energy is supplied, the bonded electrons become free and move to conduction band. And current flows. So valence band theory explains out that without supplying electrical potential, without establishing electrical potential across a solid, no electric current can be generated, because the electrons are in the form of bonds. For the conduction of electricity, there must be free. And if we establish potential difference across the solid, then what happens? The electrons are liberated from valence cell and move to where? Move to conduction band, and current starts flowing. And the power of current depends upon the power of the potential difference that you have studied in physics in Ohm's law. Now here see, we are to discuss this valence band theory in case of solid, in case of conductor, semiconductor, and last one is your insulator. Now see, as for valence band theory, as per the theory, see what theory suggests us. Here, this is your conduction band, that we see CV. CV means what? CV means conduction band. And here you see, this is your valence band, VB. that we call valence band. Valence band. In valence band, electrons are bonded. Electrons are bonded. And here, free electrons. Free electrons. That's it. In order to be free and go to the conduction band, certain electrical energy is required to be supplied. And this is called energy barrier. You are supposed that we are writing here delta E. Delta E is your energy barrier. Energy barrier. Barrier. This is your energy barrier. In case of conductors, say the case very carefully. In case of conductors, in case of conductors, the energy barrier is very small. The energy barrier is very small. Barrier is very small. Very small. In case of conductors, energy barrier is very small. There are certain metals which show high conductance. What is the idea of valence band in that case? Let us see. Metals showing high electrical conductance. Metals showing high electrical conductance. Showing high electrical conductance. In this case, what is the idea of valence band here? See, this is your conduction band that we call CV, and here the valence band overlaps with conduction band VB. Here overlap. So energy barrier, that is delta E, energy barrier is less than zero. That's why whatever potential difference we develop, that sends the electron from one point to another point. So this is the case in which a solid shows high conductance. Let us try to understand the case of semiconductors. As for valence band theory, let us see. As for valence band theory, semiconductors. Yeah. Let us see. This is your CV conduction band, and this is your VB that we call valence band, and this energy barrier delta E. Energy barrier is high. But affordable. And this is the reason that semiconductors conduct electricity. And the range of conductance of semiconductors is moderate, not high, not low. It is moderate. And here the energy barrier is high, but it is what? It is affordable. It will take more energy, no doubt, but electrons will go here if you supply some, if you establish good potential difference. But it is also of not importance. It does not have any commercial utilization. It does not have commercial utilization. Just have commercial utilization. Utilization as a conductor. So this is the case of insulator. In insulator, the energy barrier is enough, due to which if we establish high potential difference, then no current will pass. So here, what is the demerit? Demerit is what? Demerit is that if on high potential difference, low current will produce. Low current will produce. That is the case of semiconductors. Now we have to discuss the last topic, that is our insulator. So what is the case of insulator? See, insulator. In insulator, according to Boltzmann theory, the energy barrier is very high. Here it is, conduction band CV, and this energy barrier is very high. Energy barrier. This is your delta E. Energy barrier is very high. And that's the reason of calling it what? Insulator. Always remember that theoretically it is not possible that any substance can't conduct electricity. It is impossible idea in chemistry, in science. So let us discuss the thing that I want to tell you, that insulator, theoretically it is not an acceptable term. Insulator is not an acceptable term. Is not an acceptable term if we take the things on theoretical background. What is air according to you? So see, air is insulator. It means it does not contain electricity. It does not conduct electricity. But here I would like to put a question. What the question is it true? In all conditions? This is a question to think. Is it true in all conditions? Then you know that this is not true. You just remember the discovery of cathode rays, discovery of electrode. What happened? Air conducted electricity. See the reading here. The reading in that practical, that experiment was what? 0.01 mm of SG column. That's all. And here, reference line. See the reference. What is that? 1 atm is equal to 760 mm of SG column. Compare the data. The data is very less in comparison to atmospheric pressure. The pressure in discharge tube was very low. One condition was that. And second was that 10,000 potential difference volt was established across the discharge tube. And it conducted electricity. So theoretically, if somebody says that insulator exists, then the answer is it does not exist. If we apply the voltage, potential difference, more and more, under such a condition, any substance will conduct electricity. This division, this classification of solid, conductor, semiconductor and insulator is based on commercial benefits. If commercially the things are of our benefit, then we take it conductor, semiconductor, insulator. Otherwise, all substances will conduct electricity under drastic conditions. Okay. Now, we will study about semiconductors. So, what is the utilization of semiconductors? See the question first. What is the utilization of semiconductors? What is the utilization? Is the utilization of semiconductors? Semiconductors. The utilization of semiconductor is that it converts solar energy into electrical energy. It converts solar energy into electrical energy. What happens actually? See, here this is your conduction band. In semiconductors, suppose I am talking about silicon. This is the energy barrier, and here valence band is there. Valence band. When solar radiation will fall on it, then what will happen? The electrons here, these electrons will be promoted here, and they will come to conduction band. Here, the electrons will come to conduction band, and ultimately current will start flowing. Radiation produces current. That's why semiconductors are of much importance in developing what kind of energy? New energy, renewable energy. What we need today? We need to develop renewable energy. So, in order to trap renewable energy, if you want to trap this energy, trapping renewable energy, this is one technique. Solar energy into what? Electrical energy. Here we want to understand about solar cells. Normally, what remains in solar cell? Solar cell contains a small silicon or germanium chip. And what is the demerit of solar cell? The demerit is it produces very small current. Current which is too low to run any electrical device. Current is generated in solar cells, but the value is too low that we can't run any electrical device. And this thing was removed by what? By solar panels. You see, solar panel. So what is solar panel? Solar panel contains a good number of solar cells. So you must have seen solar panel like this. must have seen these kind of structures on the roof of houses. Solar panel. Solar panel. And what is this? Cell. What is this? Cell. So different cells are here. And all currents produced by solar cells are collected at one point. See here, current is collected at one point. Collected at one point, and it becomes large. It becomes large. To run any electrical device. That is your solar panel. So what kind of things are used in solar panel? What are conductors in solar panel? Conductors in solar panel. See here. The conductor in solar panel is silver. Conductor used in solar panel is silver. Why silver is used? It is used to minimize the loss, minimize the loss of current, the loss of a small current producing in solar cell, This is one thing, and tomorrow we will learn ahead of it P type of semiconductor and N type of semiconductor. Thereafter we will move to this topic, magnetic behavior of solids. For the timing, guys, I think this is enough. Thank you for watching the video. Thank you.